To divide using long division, we're going to take the numerator and write that underneath the division box as the dividend. We're dividing by the denominator, which is x plus 3. So what you're going to do, you're going to take the leading term in the dividend and divide it by the leading term in the divisor. So we want to take x squared divided by x. That equals x. So we're going to write x in the quotient, and then we're going to multiply the x with the divisor. So x times x is x squared, and x times 3 is 3x. Next, we're going to subtract everything in the parentheses. So we have x squared minus x squared cancels out. Then 6x minus 3x is 3x. Then we're going to bring down the plus 10. Then we're going to divide the leading term in this expression by the leading term in the divisor. So we want to find 3x divided by x, which is 3. That's a positive 3. Then we're going to multiply 3 times x is 3x. 3 times 3 is 9. And then we're going to subtract this entire expression. So 3x minus 3x cancels out, and 10 minus 9 is 1. So the answer is going to be x plus 3, that's your quotient, plus the remainder, which is 1, over the divisor, which is also x plus 3. Next, divide using long division. So let's write the numerator as the dividend under the division bar, and we're going to divide that by the denominator, x minus 4. Now we're going to take the leading term in the dividend and divide it by the leading term in the divisor. So x to the third divided by x equals x squared. And then we're going to multiply. X squared times x is x to the third. X squared times negative 4 is negative 4x squared. Next, we're going to subtract everything in the parentheses. So then we're going to have x cubed minus x cubed cancels out. Negative 7x squared minus a negative 4x squared. So that's the same thing as negative 7 plus 4, which is going to give me negative 3x squared. And then I'm going to bring down plus 13x. And now I'm going to divide the leading term here by the leading term in the divisor. So negative 3x squared divided by x equals negative 3x. So that's going to be the next term in the quotient. Then we're going to multiply. Negative 3x times x is negative 3x squared. Negative 3x times negative 4 is positive 12x. Next, we're going to subtract everything in this expression. So then negative 3x squared minus negative 3x squared cancels out. And then 13x minus 12x is 1x. Then we're going to bring down that minus 11, and then we're going to divide again. So we're going to divide x divided by x. So x divided by x equals 1. So we have a positive 1 in our quotient. And then we're going to multiply. 1 times x is x. 1 times negative 4 is negative 4. And then we're going to subtract this expression. So x minus x cancels out. Negative 11 minus negative 4 is the same thing as negative 11 plus 4, which will give me negative 7. So this is my remainder, and then this is my quotient. And if I wanted to write the answer out, the answer would be x squared minus 3x plus 1 plus the remainder divided by the divisor. Next, let's divide using long division, and you want to pay attention to any missing terms that you have within each expression, within each polynomial. So for example, if you notice, this goes from 3x to the 5th down to negative x to the 3rd. So we're missing a 0x to the 4th. And then we have x to the 3rd, x squared, x, and no x. So we want to be sure and put that missing term when we write it out in long division. Because if we don't, that can throw everything off. Next, let's look at the divisor. So we have x squared, but we are missing an x term, and then we have minus 7. So take the leading term in each and divide. So 3x to the 5th divided by x squared equals 3x to the 3rd. Then we're going to multiply 3x to the 3rd times x squared is 3x to the 5th. 3x to the 3rd times 0x is 0x to the 4th. And 3x to the 3rd times negative 7 is negative 21x to the 3rd. Keep in mind, when we subtract everything here, you're basically changing all the signs. So this becomes minus, minus, plus. That's another way to do that subtraction. So now 3x to the 5th cancels out. 0 minus 0 is 0x to the 4th. And then negative x to the 3rd plus 21x to the 3rd is positive 20x to the 3rd, and then we're going to bring down that minus 4x squared. So now take the leading terms and divide. So 0x to the 4th divided by x squared equals 0x squared. Then we're going to multiply back. So we have 0x to the 4th plus 0x to the 3rd plus 0x squared. Then we're going to subtract, so we are going to change all of the signs, which basically gives us 20x cubed minus 0x cubed is still 20x cubed. Negative 4x squared minus 0x squared is still negative 4x squared. Then we're going to bring down that minus 135x. So now take the leading terms and divide. So 20x to the 3rd divided by x squared equals 20x. So now we're going to multiply. 20x times x squared is 20x to the 3rd. 20x times 0x is 0x squared. And 20x times negative 7 is negative 140x. Now we're going to subtract and change all of the signs for each term. So 20x to the 3rd minus 20x to the 3rd cancels out. Negative 4x squared minus 0x squared is still negative 4x squared. And then negative 135x plus 140x is positive 5x. Then we're going to bring down that plus 28. And then we're going to divide again. So negative 4x squared divided by x squared. Negative 4x squared divided by x squared equals negative 4. And then multiply. Negative 4 times x squared is negative 4x squared. Negative 4 times 0x is 0x. And negative 4 times negative 7 is positive 28. And then we're going to subtract this entire expression, which basically means we change all the signs. So let me do that. That's what I've been doing so far. That will become positive, minus, minus. So negative 4x squared plus 4x squared cancels out. 5x minus 0x is still 5x. And then 28 minus 28 is 0. So 5x is your remainder. And then 3x squared plus 0 squared plus 20x minus 4 is your quotient. So I'm going to write the answer here. So it's the quotient 3x cubed. I'm not going to write that 0x squared plus 20x minus 4 plus the remainder 5x over the divisor x squared minus 7. When you do these problems, you want to pay very close attention to all of your steps and take your time and just kind of go step by step through the process.
Okay, number 7, we're going to factor. You always check for a greatest common factor when you are factoring a polynomial, which in this case we do not have a greatest common factor. So next we're going to look at how many terms we have. So we have 2 terms. So we have 2 options after deciding if we have a GCF to see if we can factor. Do we have squares, perfect squares, or perfect cubes? So in this case we have perfect cubes. So 25c to the third is a perfect cube, and then 64 is a perfect cube. So this looks like a cubed plus b cubed. And we factor that like this: a plus b times a squared minus ab plus b squared. So we need to identify what the a is and the b is. So 125 is 5 to the third, and then c to the third will give us 5c as our base to the third power. Take the cube root of 125, and that'll give you the 5 that you need. Then take the cube root of 64, that's 4, so that's 4 cubed. So now I can see that my a in this case would be the 5c, and the b would be the 4. So let's start factoring it out. So a plus b in this case would be 5c plus 4, then times a squared, which in this case would be 5c squared, minus a, which is 5c, times b, which is 4, plus b squared, which in this case would be 4 squared. Now let's clean this up. So we have 5c plus 4 times 5c squared, 25c squared, minus 5c times 4 would be negative 20c, and then 4 squared is 16. And so now we factored this sum of cubes. So we have sum and difference of cubes. This is a sum because we're adding here. Okay, number 16, factor the polynomial completely. So when we factor a polynomial, we want to always first check and see if we have a greatest common factor or a GCF that we can factor out. So we have 15x to the 8th, 27x to the 5th, and 9x squared. So what's the greatest common factor between 15, 27, and 9? 3 is the greatest common factor between those 3 coefficients. Now let's look at the variables, the x. So what's the greatest number of x's all 3 have in common? It'll be x squared. You're getting the GCF, you want to make sure they all have the same variable. And if it's a part of your GCF, and if they do, you want to take the smallest exponent. So we're going to factor out the GCF, 3x squared, and we're going to write what's left over in parentheses. And you're basically dividing everything by that GCF. So 15x to the 8th divided by 3x squared would be 5x to the 6th. 27x to the 5th divided by 3x squared would be 9x to the 3rd. And then 9x squared divided by 3x squared would just be 3. So this is our final answer here. All right, let's keep going. 17, factor by grouping. So we factor by grouping when we have 4 terms, which we have here. So we're going to start by grouping the first 2 terms, and then we're going to group the last 2 terms. Okay, so within the first group, factor out the GCF. So between 6x squared and negative 10x, the greatest common factor would be 2x. So we factor that out. We would have 3x minus 5. Now, factoring by grouping, we want to do the same thing, take out the GCF here, but our goal is to get another 3x minus 5. So keep that in mind. That can help you figure out what to factor out. So I need to get a positive 3x in parentheses. I'm going to factor out not just a 3, but a negative 3. So that when I factor it out, I'll get that positive 3x that I need and that minus 5 that I need. So now that we have factored out the GCF from each pair, now we're going to write what's in common between both of these, which would be 3x minus 5, and then just write what's left over on the outside, 2x minus 3. So we basically factored out 3x minus 5 and wrote it down, and when we factored it out, we were left with just 2x minus 3. So this is our final answer. We factor by grouping. And remember, you can always double check your factoring by multiplying your factors back together, and you should get the original problem that we started with. Okay, so number 18, factor the trinomial. So first we want to always check for a GCF. There is not a GCF here to factor out. So next we're going to look at how many terms. It's a trinomial, so there's 3 terms. So we need to set this up. Our leading coefficient is a 1, which is great because it makes it a little easier to factor. So we're going to start with 2 sets of parentheses, and they're going to start with an x for each of them because x times x will give us that x squared that we need. Now, this is our standard form. So if c is negative, so negative c means we're going to have different signs in our factors. So basically we want to have a positive and negative. Now we need to figure out the 2 numbers that multiply to give us negative 42 and add to give us 1. So if we think of 42, if we think of factors or 2 numbers that multiply to give us 42, if I think of 7 times 6, 7 times 6 is 42. Now I need to add the 2 numbers together to get 1, and they need to multiply together to get negative 42. And we already have here that one of them needs to be a negative number. So when c is negative, you have different signs. And then if b is positive, which it is in this case, the larger factor takes the positive sign. So it'll be positive 7 and negative 6. And that's because 7 times negative 6 equals negative 42, which is what we needed to happen. And then 7 plus negative 6 gives me that 1 that I need, which is the 1 here, which is b. So our final answer is x plus 7 times x minus 6. All right? And then just to finish this up, so if c was positive, you would have the same signs. And then depending on the b, so if c is positive and b is positive, you would have plus plus. If c is positive and b is negative, then you would have minus minus. So those are helpful tricks to help you set up your factors. Okay, number 19, factor the trinomial. So here the leading coefficient is not a 1. Before I get started, check for a GCF, and we do not have a GCF here. So leading coefficient is not a 1. So we're going to have to start by taking a times c. All right, so 7 times negative 10 is negative 70. Now this is the number that I'm going to use to find those 2 numbers that multiply to give me negative 70 and add to give me 9. So if I list some numbers that multiply to give me negative 70, let's see, I've got 7 times 10, I've got 5 times 14, 2 times 35, a lot of combinations here. It's negative, so I need to have one of these to be negative, and I want to add them together to get 9. Like I said before, c is negative, so they're going to be different signs, and then the b is positive, so the larger number gets the positive sign. So I'm going to set it up like this. I'm going to use grouping to factor this, so I'm going to rewrite 9x. So I'm going to write 9x using my negative 5 and 14. So it doesn't really matter how we set it up. I'm going to write 14x minus 5x. That equals 9x. So all I did was rewrite 9x using 14 and the negative 5. Okay, so now I'm going to bring down everything else. 7x squared and the minus 10. So now I'm going to factor by grouping. So I'm going to start by grouping the first pair and then the second pair. So the GCF of the first pair would be 7x. And then when I factor that out, I'm going to be left with x plus 2. Now, I'm factoring by grouping, so I need to get another x plus 2. So the GCF between negative 5x and negative 10 is going to be negative 5, so I can get another x plus 2. Because negative 5 times x is negative 5x, and negative 5 times 2 is negative 10. And then now I'm going to write the x plus 2, and then I have 7x minus 5, and that's my final answer, factored out. So there's a ton of factoring methods, and depending on which ones you prefer, we're going to show you another factoring method that you could use, and whichever one you use is completely up to you. This one is the AC method, trial and error, AC, there's so many names, but if you like to factor by grouping, this is a good method to use. But here's another method.
Let me go back one slide. I'm going to show you guys another method to use. So if you have a trinomial with a coefficient of 1, you're going to follow a few steps. Like in the previous problem, you write your empty sets of parentheses, then you are going to square root this first term, which gives you an x and an x. Then you are going to bring down your first sign, which is a plus, multiply the two signs together, which gives you the second sign. So positive times negative is a negative. And then you don't have to deal with the sign issue anymore, and you're basically just looking at the plain 42 without any signs, and look for the factors. When you have different signs, the factors must subtract. If you have same signs, the factors must add to give you the middle number, which is 1. And the factors will be 7 and 6. To not have any issues with the signs, always put the larger one of the two factors first and the smaller one second, and it will work out 100%. Always with your signs. And now going to the next problem and also using this method, I'm just going to copy it down real quick. If you wish to use the Columbium method, the first step would be multiply the first number by itself and the last number by the first. Rewrite the problem. So we have 7 times 7, which is 49x squared plus 9x, leave the middle term alone, and then 10 times 7 is negative 70. So now, like in the previous problem, when you had a coefficient of 1, you're going to square root this first term, which is 7x, then bring down your first sign, multiply the two signs together, positive times negative is negative, and find the factors of this last number, which is 70, different signs again, so the factors must subtract to give you the middle number, 9, and in this case, you have 14 and 5. 14 times 5 is 70, and 14 minus 5 is 9. Always write the larger of the two factors first and the smaller second, and you have no issues with your signs. Now remember how we multiplied in the beginning by 7? We have to divide by the 7. And as you can see, only one of the two factors is divisible by 7, which would be the left side. I'm just going to put a 1 here because nothing changes with a 1. And then rewriting the 7 divided by 7 is 1x, and 14 divided by 7 is 2, and this stays the same, and that will be my answer. So these are two different methods, and there are plenty of more factoring methods out there. Just try to find one that 100% works for you and stick with it, and you are safe to go with factoring. And it's really important to learn factoring because not only in this class but every other math and science class you will need and see factoring. So you need to have a method that really works for you.
So number 20, factor completely. So always look for a GCF first. We do not have a GCF between 4y squared and negative 9. So now we're going to look at how many terms we have. We have 2 terms, okay? So we either have perfect squares or perfect cubes. If we don't have one of those, then we're done. We can't factor it. So we have perfect squares, and it's the difference. We're going to use a squared minus b squared equals a plus b times a minus b. So if we take the square root of each term, that will give us the base for each term in a squared minus b squared form. So the square root of 4y squared is 2y So that's my a, because 2y squared is 4y squared. And the square root of 9 is 3, so that's 3 squared, which equals 9. So now I can see very clearly that 2y is my a and 3 is my b. So to factor this out, I would say 2y plus 3 times 2y minus 3. And I am done factoring. So remember, you do want to know your factor patterns, so difference of squares, sum and difference of cubes. You need to have those memorized. It'll be much easier to factor if you have those memorized. And then factoring trinomials.
So find the domain of the rational function. So this is a rational function. So remember, to find the domain, we never want 0 in the denominator. So whatever over 0. You never want 0 in the denominator. Okay? So no 0 in denominator. So we have a variable in the denominator. So let's figure out what would make the denominator equal 0, and we're going to exclude that from the domain. So we're going to take our denominator, which is x minus 7, and set it equal to 0 to figure out what would make the denominator equal 0. And so x equals 7. So if we were to plug in 7 into our denominator, we would get 0 in the bottom, and that's a no-no. So for set builder notation, this says all values of x such that x is a real number and x does not equal, basically we do not want x equal to 7, because if it equals 7, that would be undefined. And now for interval notation, for me, I think it's easier to draw a number line first to kind of get an idea of how it would look in terms of all the real numbers, and then graph that, and then convert that to interval notation. So right now, basically, this is saying that x is all real numbers, everything on this number line, except at 7. So let's mark 7. Let's say 7 is there. We're not including 7, so we're going to use an open circle to represent that we do not want to include 7, but it's all the real numbers except 7. So it's everything over here and everything back there. Okay? So let's write what that means. So on this side of the number line, that's negative infinity. And on the right side of the number line, that's positive infinity. And you always want to write your interval from left to right. So starting from the left, we're starting with negative infinity. You always use a parentheses by infinity, comma, all the way to 7. We are not including 7, so we're going to use parentheses. And then we have another interval, which is the right side of 7. So we're going to say union 7 with the parentheses, because we're still not including 7, comma, positive infinity, and then parentheses. So this is interval notation, and then we already wrote set builder notation at the top. All right. Okay, evaluate the rational equation for the given value. F of x equals x minus 1 over 8x plus 3, and we want to find f of 4. So all that means is we're going to plug in 4 everywhere we see x. So f of 4 would mean that everywhere we see x, there's an x, and there's an x, we're going to plug in 4. So we have 4 minus 1 over 8 times 4 plus 3. And so 4 minus 1 is 3 over 8 times 4 is 32. And we have plus 3. So then we're going to continue to simplify the bottom. 3 over 32 plus 3 is 35. And then for the question here, it says to write your answer as a reduced fraction or an integer. And we can't reduce this fraction further, so this will be our final answer, 3 over 35. Question 3, simplify the rational expression. So let's see what we've got. So right now, we can factor the bottom. So let's factor out a GCF from the bottom, which the GCF of the denominator is 5 here. So we'll factor out 5, and then we're left with x minus 3. And at the top, let's just rewrite what we have, 3 minus x. So if you look at it, we almost have something to cancel out. It's close. We have an x here and an x up there and a 3 up here and a negative 3 down here. But right now, we can't cancel anything out. So in this situation, we want to factor out negative 1 from the top, okay? Or just a negative, either way. So let's factor out negative 1 at the top. And what that is basically going to do is going to change our signs at the top. Because if we factor out a negative 1 from 3, we'll have negative 3. And if we factor out negative 1 from negative x, we have positive x. And remember, when you're factoring something out, you're doing the reverse of distributive property. So remember that negative 1 times negative 3 is positive 3. And negative 1 times x is negative x. So by factoring out that negative 1, we just did reverse distributive property. And now I'm going to just rewrite the bottom, 5 times x minus 3. And if you notice at the top, we do now have the same factor going on. We have negative 3 at the top, negative 3 in the bottom, x at the top, and x at the bottom. And if you want to rewrite it so it looks the same, you can do that. This is a positive x, and that's a negative 3 over 5 times x minus 3. So now you see that your x minus 3 factors do cancel out. And then all you're left with is negative 1 over 5. And that's our final answer. Okay, question 4. Divide the rational expression. So we want to factor everywhere possible after doing what I call keep, change, flip. So when we divide by any rational expression, we're going to use keep, change, flip. That's a short way of saying multiply by the reciprocal. So that means that we're going to keep the first rational expression the same. We're going to change division to multiplication and then flip the second rational expression. So it's going to be y squared minus 14y plus 48 at the top, and then y squared minus 6y minus 16 at the bottom. All right, so now we've got some factoring to do. So let's see, at the numerator in the first rational expression, we have a GCF of y, so I'm going to factor that out, and then I'll have y squared plus 6, and then at the bottom I have a GCF. No, I don't have a GCF, but I do have difference of 2 squares. So this is the same thing as y squared minus 6 squared. So then that would be y plus 6 times y minus 6 times. Now let's factor the second rational expression. So we have a trinomial. So the way I factor trinomials, I first look at the leading coefficient. It's a 1. So I'm going to go ahead and set up my binomials, y and y. Now, let's look at the 48. So at first, let me get my signs together. So I like to use the sign rules when I factor trinomials. So we always look at that first sign, which is negative 14. I just keep that sign, bring that sign down, and then to get the next sign in the factors, I multiply the negative and the positive in my trinomial. Negative times positive is negative. So this is also going to be negative. And because I use the sign rules, when I get my factors that need to go into the binomials here, I always put the larger factor first. So I need 2 numbers that multiply to give me 48 and are going to add, because 48 is positive, to give me 14. And so that would be 8 and 6, because 8 times 6 is 48, and 8 plus 6 is 14. So I have 8 and 6. So now I'm going to factor the bottom. So I'm going to set up my binomials. The leading coefficient is a 1, so I can go ahead and start off with y and y. And so let's take my signs. The first sign is negative, so I'm going to bring that here. And then I'm going to multiply the signs in the trinomial to get the second sign. So negative times negative is positive. That's my second sign. So now I need two numbers that multiply to give me 16, but subtract, because it's a negative 16, to give me 6. So those two numbers would be 8 and 6. 8 and 2. 8 and 2. Because 8 times 2 is 16, but 8 minus 2 is 6. And remember, I always put the larger factor first, so I have 8 and 2. And so now I've factored everything, and so now it's time to cancel out any common factors at the numerator and the denominator. So let's see, I've got y minus 8 cancels out, and I have y minus 6, and y minus 6 cancels out. And that actually is all the canceling I can do. You may want to cancel something with the y plus 6 in the bottom and the y squared plus 6 at the top, but those are not the same factors. So we cannot cancel those out. And there's no single y at the bottom to cancel with this y at the top. And there's no y plus 2 to cancel with the y plus 2 in the bottom. So now we're just going to write what we have left, and that's going to be our final answer. So y times y squared plus 6 divided by y plus 6 times y plus 2. And you know, if this was a typo, it would have been really neat if this started off with y squared plus 6y, because then this would be just y plus 6 and we could cancel some more. But it's not, so this is going to be our final answer here. Okay, question 5. Perform the indicated operation to simplify the rational expression. So in order to add and subtract rational expressions, the same thing as fractions, you must have a common denominator. The denominator must be the same, which in this case they are x minus 3, x minus 3, x minus 3. So if they have the same common denominator, you just keep that denominator and then combine the top. So the top, we have x squared minus 7x plus 12. And then now to simplify it, we have to factor the numerator and see if we can cancel anything out. So look at the leading coefficient. It is a 1, so I can go ahead and set up my binomials. I'm going to take the first sign here, which is negative, so that's the first sign in my first binomial, and then to get the next sign in my second binomial, I multiply these two signs. Negative times positive is negative. So there we go. And now I need two numbers that will multiply to give me 12 and add, because 12 is positive, to get me 7. So those two numbers would be 4 and 3. So I'm going to put 4 and 3. In this case, it wouldn't have mattered where I put the 4 and 3, because they're both going to be negative, but just to be consistent, I always put the larger factor first, because it does matter when I have different signs in my binomials. So now I have x minus 3 at the bottom, and then now I can see x minus 3s are going to cancel, so then all I'm left with for my answer is x minus 4. That's my final answer there. Okay, question 6. So now we're subtracting. So pay attention to what operation you're doing. But we don't have common denominators right now. And there's no way to know what the common denominator should be without factoring the denominators to see what all you need to include in your greatest common denominator, or greatest common factor, least common denominator, sorry. You need a least common denominator, so we need to factor to figure out what factors we need to consider. So I'm going to just rewrite them here. So x over Let's factor the first denominator. This is the difference of two squares. This is the same thing as x squared minus 4 squared. So that would be x plus 4 times x minus 4 for that denominator, minus 3 over, now we need to factor this trinomial. So the leading coefficient is a 1, so I can set up my binomials. The first sign is positive, and then multiply the signs to get the next sign, which would also be positive. And I need two numbers that will multiply to give me 4 and add to give me 5, so that would be 4 and 1. So now we need a least common denominator. So the least common denominator needs to include all of the factors in all of the denominators. So pay attention. So let's see, the first rational expression has an x plus 4. That needs to be in there. It also has an x minus 4. The second denominator has an x plus 4. We've already taken care of that. But it also has an x plus 1. So your least common denominator would be this entire expression, x plus 4 times x minus 4 times x plus 1. So what you want to do is multiply both expressions by that LCD, and what will happen is that you will cancel out the denominators, and then you can simplify from there. So basically I'm multiplying all of this by that LCD, and then this one by my LCD. So let's see what happens. Let's see, x plus 4 is cancel, x minus 4 is cancel, and so at the top I'm just going to have x times x plus 1. Okay, and now over here, the second rational expression, you see the x plus 4 is cancel, the x plus 1 is cancel, and then all I have left is minus 3 times x minus 4. So now let's just distribute. X times x is x squared, x times 1 is x, negative 3 times x is negative 3x, and negative 3 times negative 4 is positive 12. And then we're going to combine like terms, which would be here. X minus 3x is negative 2x. And then we'll just bring down our x squared plus 12. And we don't have to factor, we're just trying to simplify. And this actually wouldn't be factorable. So this is our final answer here. X squared minus 2x plus 12. Question 7. Simplify the complex fraction. Spell error. That's why I'm a math teacher, right? Fraction. Okay, so least common denominator. So there's a few, you could actually use a couple of ways, but I think the most direct way would be to get the least common denominator for the entire fraction and then multiply everything by that. The numerator here, we have a 1 minus 6 over x. So the denominator for the 1 is just 1, and then we have a denominator of x. So right now we need to definitely include x in our least common denominator. And if we look at the denominator here, we have x minus 36 over x. The denominator here at the bottom is just x. So our LCD is simply x. So we're going to multiply the top by x and the bottom by x. So when we do that, x times 1 is x, and then we have minus 6 over x times x divided by x times x minus 36 over x times x. Okay, so now let's see what's going to happen. So 1 times x is just x. And then negative 6 over x times x, your x's cancel out, and I'm just going to have minus 6. So that's my numerator. And then at the bottom, x times x is x squared, and then negative 36 over x times x, the x's cancel out, and I'm left with just negative 36. And then now I can factor the bottom. That's the difference of two squares. I'm going to have x plus 6 times x minus 6. And then I'm going to cancel out common factors, which would be x minus 6 and x minus 6. At the top now, I'm going to have just a 1, because when I cancel out, what's happening is x minus 6 divided by x minus 6 equals 1. So that's why we're left with just 1 at the top. And on the bottom, we just have x plus 6. So that's our final answer here. Solve the rational equation and check your solutions. So check for extraneous solutions. So again, it's another problem where we want to multiply by the least common denominator. So we have x and 8. So if we multiply those together, our LCD would be 8x. So we want to multiply everything by 8x. So we'll have 8x times 8 over x plus 8x times 7 over 8 equals, don't forget to multiply here, 8x times 1. So let's see what's going to happen. X divided by x is 1, so we're just left with 8 times 8. 8 divided by 8 is 1, so we're just left with plus x times 7 is 7x equals 8x times 1 is just 8x. 8 times 8 is 64 plus 7x equals 8x. Subtract 7x because we're solving the equation. So we have 64 equals 1x. So that means that x equals 64. And so if we go back and check our equation, you want to go and make sure if you're to plug in 64 into your equation, you wouldn't get something undefined. And we wouldn't. If we plug in 64 in for x, we would be left with 8 over 64, which is completely fine. And you can also actually check your answer by actually plugging it in if you want. So we're going to plug in 64 in for x. So that would be 8 over 64 plus 7 over 8 equals 1. And you can actually put that in your calculator if you want. 8 divided by 64 plus 7 divided by 8. And you will get 1. So 1 equals 1. That's correct. So we have verified that our answer is correct. Question 9. Solve the rational equation and check your solutions. So we have m minus 10 over m equals 9. Let's multiply by the least common denominator, which would be m. Because this first expression, m, that has a denominator of 1. And then the denominator for the second expression is m. And the denominator for the 9 is just a 1. So 1 times m is just m. So we're going to multiply everything by m. Okay, so m times m minus m times 10 over m, we distribute there, equals 9 times m. M times m is m squared. M times 10 over m, the m's will cancel out to 1, so we'll have minus 10 equals 9m. So we have m squared here, so we actually have a quadratic. So we need to move everything to one side and set it equal to 0, factor, and solve. So I'm going to subtract 9m. It's going to be m squared. I'm going to write minus 9m before the negative 10, so I can put it in standard form, equals 0. So I have a trinomial to factor. So I'm going to set up my binomials. My leading coefficient is a 1, so I can bring down my m and m. Let me do my sign rules. Bring down the first sign, which is negative, and then multiply these signs to get the next sign in the binomials. Negative times negative is a positive. So I need two numbers that will multiply to give me 10 and subtract, because 10 is negative, to give me 9. So that'll be 10 and 1. And so I want to put the larger factor first. So it's going to be 10 and 1. And so remember, I'm trying to solve this. So in order to solve this, I'm going to use the zero product property, which basically means I'm going to set each factor equal to 0 and solve. So m minus 10 equals 0. So if I add 10 to both sides, I have m equals positive 10. And then m plus 1 equals 0. If I subtract 1, m equals negative 1. That's my other solution. And then you want to check your solutions. So we got to go back and make sure if I were to plug in 10 in for m, I wouldn't get an undefined answer. And make sure if I plug in negative 1 in for m, I wouldn't get an undefined answer. So we can check that. So I can plug in the first one. So 10 minus 10 over 10 equals 9. So that'd be 10 minus 1 equals 9, and that's true. Let's plug in negative 1 in for m. Negative 1 minus 10 divided by negative 1 equals 9. So negative 10 divided by negative 1 is positive 10. Bring down my negative 1 equals 9. And negative 1 plus 10 is 9, so that checks as well. So these are our solutions. 10 and negative 1. Question 10. Solve the literal equation for the specified variable. So h equals 2a divided by capital B plus small b. So let's see, and we're solving for b. All right, so first let's get this out of a rational expression. So let's multiply both sides by b plus b, big B plus little b. So big B plus little b times h equals big B plus little b times 2a. So we multiply both sides by b plus b over b plus b. There we go. All right, so now let's see what happens. So on the left, let's just distribute the h. So we have big B times h plus little b times h equals b plus b cancels with b plus b, so I just have 2a equals 2a. I'm solving for big B, so let me move this plus bh to the other side, the small bh, minus bh, minus bh. That cancels out, and I have big B times h equals 2a minus little b times h. And then again, I'm solving for big B, so we're going to divide by little h, divide by little h. So that will cancel out, and all I will have left is big B. Then I have big B equals 2a minus little b times h divided by little h. And that is my final answer. You don't have to split this up. You could if you wanted to. It's not required, but you could do 2a over h minus bh over h, and then you could see those h's cancel and say that's 2a over h minus b. You could do that, but this form is fine as well. Question 11. Anthony and Carmen both work for Smith Landscaping Company. Anthony can finish a planting job in 3 hours, while it takes Carmen 5 hours to finish the same job. How long will it take for them to complete the job if they were working together? So the way that I answer this, I set it up like this. And I'll tell you, you can do this every time. This is a pretty consistent way of solving these type of work problems. So let's start with Anthony. So Anthony can finish planning a job in 3 hours. So let's just assume that he can do 1/3 of the job in 1 hour. And then plus Carmen takes 5 hours to do the same job. So we can say that it would take her an hour to do 1/5 of the job. And we want to know how long it will take them to do it together. So we'll say equals 1 over t for time. And I also think of time as t equals together, but t really means time here. Okay, so then we're just going to solve this rational equation. We're going to multiply by the least common denominator. So we have a 3, 5, and a t. So 3 times 5 times t is going to give me my least common denominator, which is 15t. So now we're going to multiply everything here by the least common denominator. So let's multiply 15t, everything here, 15t, everything there. So now let's distribute. So 15t times 1 over 3 plus 15t times 1 over 5 equals 15t times 1 over t. So 15t times 1/3, if we look, 15 divided by 3, 3 goes into 15 5 times, 3 goes into 3 1 time. So now we just have 5t times 1, so that's just 5t. All right, so now let's see, 15t times 1 over 5, 5 goes into 15 3 times, 5 goes into 5 1 time. So I have 3 times t times 1, so that's just going to be 3t equals 15t times 1 over t. T divided by t cancels out to 1. So I just have 15 times 1, which is 15. So 5t plus 3t is 8t equals 15. And then we would divide both sides by 8 to solve for t. So t equals 15 divided by 8. So the exact answer as a fraction would be 15 over 8 hours. Now then it says it will take them about blank hours to complete the job if they're working together. Let's divide 15 divided by 8. You can use your calculator. That ends up being approximately, well actually exactly, 1.875. So we can round that to about 2 hours. But the way we set this up by saying 1/3 plus 1/5 equals 1 over t, that's a consistent way of solving these. So if this was Anthony was planning a job in 8 hours, it takes him 8 hours, Carmen takes her 2 hours, how long will it take them to do it together? You would just change the numbers here. But this is a very consistent way of solving problems like this. Okay, so on a map, the length of a nature-centered trail is 9.1 centimeters. If the scale is 1 centimeter to 25 kilometers, what is the actual length of the trail? Round the nearest tenth, if necessary. So we're trying to convert centimeters on this map into kilometers. And the way we're going to do that is we're going to use this scale here. 1 centimeter equals 25 kilometers. So 1 centimeter equals 25 kilometers. So we have 9.1 centimeters, right? And we're going to use a proportion to solve this. So we want to figure out 9.1 centimeters is proportional to x kilometers. And that's what we're solving for. The actual length of the trail, that's going to be this. Okay? And that's proportional to the scale. So the scale says that 1 centimeter is the same as 25 kilometers. And so when we're doing proportions, since we have centimeters at the top, we need to have centimeters at the top in your ratio here. And then we need to have kilometers at the bottom so that they're in the same order. Okay? So now our scale, we're using that here, is 1 centimeter is proportional to 25 kilometers. And so now we have a rational equation to solve. So we can just cross multiply. So we have 9.1 times 25 equals x times 1. So basically 9.1 times 25 equals x, which is what we're trying to find. And you can use your calculator to do 9.1 times 25, and you would get 227.5 equals x. And it says round to the nearest tenth, and that's actually the entire answer. And we're going to use our proper units, this is going to be 227.5 kilometers.